So in this tutorial, we want to talk about organic chemistry. We want to talk about hydrocarbons, and we're going to cover the first homologous series group, which is called alkanes. So let's look at some general things that you need to know and understand about alkanes. So firstly, the word hydrocarbon simply means a compound that is made up of hydrogen and also carbon. So if you look at those two molecules, by the way, that's called a displayed formula, where you have to show all the covalent bonds that are in a molecule. So if you look at those two molecules, you realize that the one to your left, called butane, is a hydrocarbon, whilst butanol cannot be classified as a hydrocarbon because it also contains oxygen. So hydrocarbon is made up of carbon and hydrogen only. So that's a word you need to be familiar with. So alkanes are hydrocarbons in the sense that they are made up of hydrogen and carbon only. They also have a general formula which gives you the ratio of carbons and hydrogens that are in each molecule. So like we said, it's a homologous series, and our molecules, they are getting bigger by one carbon each. So you have the first molecule there, methane, with one carbon, ethane with two carbons, propane with three carbons, and butane with four carbons. So those are prefixes actually representing specific numbers. So meth means 1, eth means 2, prop means 3, but means 4, pent 5, hex 6, etc. So when you know the number of carbons in an alkane, you can use the general formula to calculate the molecular formula or the number of hydrogens that are in that molecule. So our general formula is CnH2n plus 2. Okay, so let's suppose you have an alkane with 3 carbons. Then you can use that formula to calculate the number of hydrogens. So our N is equal to 3. So that means that our hydrogens, the number of hydrogens, is going to be 2 times 3 plus 2, which gives us 8. So the formula becomes C3H8. So this is how you use the general formula. Let's look at this example. Octane is an alkane with 8 carbon atoms. What is its molecular formula? So you can use the general formula as before. Once you know your number of carbons, N is equal to 8. So you say 2 times N, 2 times 8, plus 2 for the number of hydrogens according to the general formula. Then you get your 18. So that's the formula. You should also know that these alkanes are said to be saturated compounds, meaning that the carbons in each of these molecules is going to form its maximum number of bonds, which is 4. So carbon forms all the 4 bonds in alkanes, and there are no double bonds. Double bonds are the ones that are referred to as unsaturated. So when you have single bonds, we say the molecule is saturated. So alkanes are saturated. Okay, so let's look at some properties of alkanes that are important. So as we move down the group, as we move across this series, as our number of carbons increase, we start to see some trends. The first trend is in boiling point. So our boiling point increases as the number of carbons increases in this group. So the first 4 alkanes, they are gases, but as the number of carbons continue to increase, for example, more than 4, we start to see liquids in that group. And as our number of carbons continue to increase, we start to see solids. So that is the trend in boiling point. There's another property called volatility, which simply means something that can evaporate more easily. So we see that the first 4 compounds there, which are gases, are the most volatile. And so volatility is going to decrease with increase in number of carbon atoms. So when we get to alkanes that have very large number of carbons, we can use another term which is called viscosity. So these ones are viscous, meaning that they are sticky, just like honey. So as you move, as you increase the number of carbon atoms, you start to see more viscous alkanes. And at the top there, where you have a lesser number of carbons, you have more volatile alkanes. Okay, let's talk about the reactions. We are going to talk about here combustion. So most of our alkanes can be used as fuels. That is the most important use of our alkanes, and they burn where there is sufficient oxygen to produce carbon dioxide and water. So this is called complete combustion. So we can also refer this to as oxidation, since our hydrogen and oxygen are going to combine with oxygen. So this is also called oxidation. Okay. So how would you represent this using equations? You must be able to write a balanced equation for the combustion of our alkanes. So as before, you're going to have your hydrocarbon, your alkane plus oxygen to give carbon dioxide and water, and you have to check whether it's balanced. We looked at this in other videos. That would be another example, the combustion of a very large alkane there. So you just have to check the number of carbons and hydrogens. I'm going to show you a general formula that you can use to balance these equations in another video, so you can hang on for that. So this is it for now. So to summarize here, we need to understand that alkanes are referred to as a homologous series, and we're going to look at other homologous series groups later on. So a homologous series group is going to have molecules with the same chemical reactions, same functional group. So the functional group for alkanes here is our single bonds, carbon to hydrogen, carbon to carbon bonds. So, and you're going to realize that in other textbooks they say alkanes do not really have a functional group, but just know that those single bonds are what we refer to as the functional group. So they have the same functional group, they have the same general formula, and they have different properties and some small differences, as you saw. And for the reactions of alkanes here, you need to understand that they react with chlorine in a substitution reaction, which requires light and UV light, and they also undergo combustion reactions, as we saw. So I'll meet you in another video.